Hello everyone, welcome to today's Knowledge webinar. Create, evaluate, and visualize your design faster with Inspire Studio, Part 2. Inspire Studio is the new solution for innovative designers, architects, and digital artists to create, evaluate, and visualize design faster than ever before. Get ready to get inspired with today's newest episode. And today's webinar presenter, Arjun Ajjampur, is a product specialist at Altair Inspire Studio. He has master in industrial design with over 10 years of experience working both as a designer and a 3D modeler. Now, let me tell you a little bit about Knowledge. Knowledge is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, and faster service. Check us out at knowledge.com. And we also would like to get you a good look at Inspire Studio by issuing a 90-day free trial. So this is amazing. 90 days, do whatever you want with it, and you can claim the free download by emailing sales@knowledge.com. So check it out. You just need to try to love it. And now, without further ado, I'm going to share Arjun's screen so it can take you through the newest feature of Inspire Studio. Take it away, Arjun.
Thank you, Barbara. Good morning, good evening, everybody. No matter where you're joining from, welcome to this webinar on Inspire Studio. As Barbara mentioned, this is a new product in terms of user interface and some features that is out by Altair. And Inspire Studio is mainly catered at industrial designers and 3D modelers alike for them to visualize and evaluate their ideas faster. So for those of you familiar with our previous webinar, in part 1, we did cover a lot of the introduction aspects of Studio, and I will do the same in this webinar, but I'll try to keep it to a smaller part of the webinar. As I was saying before, we've positioned Studio in a unique aspect in terms of its abilities of sketching, construction history, rendering, and animation. We refer to Studio as a hybrid modeler because it's really a very competitive software in terms of features. You get curves, you get surface modeling, you get solid modeling, you get polygonal modeling, construction history, and you get completely integrated rendering with the industry-leading Thea render integrated into it. What is the reason I would expect somebody to try Inspire Studio? It's just that for the cost of the product, it brings tremendous value to your design process. And I'm not just saying because it has all these tools incorporated within the program, but also just the fact that you can do some really quick changes with your design to evaluate some of your ideas. I want to share a quick video here wherein this model is built using some symmetry tools and polynorms, and you can see that with just a few clicks, you can really look at how your model will change and evolve in a matter of seconds. And this is the overarching theme of Studio. It just lets you change your mind at any point without worrying about any downstream operations that might break. And even if they do break, it's really easy to fix many of the things. Now, moving on to some other features of Studio. We've spent a lot of effort into revamping the way users interact with the program. So you can look at the completely new user interface, very intuitive, very easy to understand. And I will go through some of these, of course, when I give the demo. So we have introduced some very quick ways to access tools via the tool belt. Most of the tools are categorized based on what they do, and we have very high quality icons that exactly tell you what you're selecting in terms of the tool. When it comes to polygonal modeling, which will be the focus of today's webinar, is how can it bring value to your design process in terms of how quickly you can come up with a concept and how you can modify it on the fly. People familiar with programs such as other polygonal modeling programs might feel at home. We are really working hard to add more features, and we hope that you will appreciate what you see today. So here's a quick difference or a comparison between a parametric CAD that takes 120 minutes and a polyNURBS concept that can be dished out in about 15 minutes. And today I will show you how quickly you can create some really cool designs in a matter of few minutes as opposed to hours. So one of the reasons we are pushing the polyNURBS concept out is because we are positioning Studio in a very unique segment, wherein we are catering to not just product designers, but also automotive and aerospace designers. And that means you can evaluate your designs and figure out whether some of the core criteria like drag and other automotive features are as expected, and you can change it to visualize the updated geometry instantly. So as you can see here, we are talking about really one-day turnaround for a very complex model. And a very quick example of how you would start. I'm going to cover some of these topics, but of course we will not have the time to design a car completely, but the crux of the polygonal modeling is pretty much this. You start out with a simple block and you start sculpting, and you can add or delete details as and when you think it's appropriate in the modeling phase, because overall you want to build the model in a very simple format, but as you progress you can add more and more details. So here you can just see how quickly you can add some loops and bridges across edges to create a well-formed polyNURBS body. And this model here is a little bit more detailed in terms of features, and of course takes a bit more time to get to this level. But with some advanced tools like symmetric modeling in polyNURBS, you can see that changes that you make in one side are instantly applied to another. And I'm going to also show you some features where you can add quick sharpness to edges. You can also align some of the points to certain curves of a certain interpolation so that you can move the points on the curve, and the underlying geometry also moves with it. So these are small improvements that we are adding in every release, and you will see that it really makes your process a lot faster and more intuitive. So some quick examples, as I was saying, that Studio also includes a built-in interactive render with an industry-leading physically accurate rendering engine. For those of you familiar with Thea, and if you use Thea for SketchUp or Thea for Rhino, Thea is also included as the rendering engine in Studio. So basically it comes built into the environment. So before I jump into the live demo, I just want to quickly show you the images that were created only in polyNURBS. So here you can see that although you might be tired of looking at cars, but they are objects that express such fluidity. So there is a reason why designers or companies use these models, is because they just bring in the complexity into any modeling process, and you can appreciate that it's not easy to achieve. And using just polyNURBS tools, you can do it in Studio. So with that, let me just jump into the program itself. And here is the program, and you can see it's a very minimal looking user interface with all your tools at the top. And right now I'm in the polyNURBS ribbon, but you can see we have some for sketching, curves, surfaces, and so on. And you can also find these tools in the quick tool belt, which is Alt and right click, and you can select the tools. And we have several combination of modifier keys that brings up different tool belts. So I have a sketching tool belt for Alt and Shift. I have a rendering tool belt for Alt, Control, and Shift. And for only Control and Alt, I have the polyNURBS tool belt. Of course, these are all completely customizable. If you go to File, Help, and Customize Tool Belts, you can customize all of these. And eventually, you'll probably create one tool belt that has a mix of tools that you're most commonly using. And this just makes it faster as opposed to traversing all the way here and finding what you need. Okay, so with that, with the boring stuff out of the way, let me quickly jump into what you can do in Studio. So as I was saying today, I want to focus a little bit more on the Polynubs tools that have become a very critical element in our development of this product. And a lot of people who use Studio find it very easy to adapt and to learn, and also it becomes an integral part of their design process. So here I want to start off by showing you what we're going to do in this webinar. So let me open one Polynubs model I just created. So this is just a mug with a coaster attached. So you might have seen something similar online, but maybe you want to create something for yourself with your own identity and maybe print it out. So we're going to look at how to do this. So as you can see here, when I select the object, there is nothing else in the model browser that we call it here. There's only one object called a polycylinder because that's what I used to create this. And right now, when I double click this, you can see that I'm in vertices mode. So all of these dots are called vertices. When I hit S on the keyboard, I will go to edges mode, and D will be the faces mode. And you can also find these here, all the options on the top here, vertices, edges, and faces. Now, with each of these, you have their own options. So we'll look at that in detail in a little bit. So let me start. How do we start any Polynub? So there are several ways. I'm going to just keep this in the view here so that you can compare it. Here on the top, you have some objects like primitives that you are familiar with, like polyplane and polycube, polyquad ball, and each of those they cater to a different workflow. So for this particular model, I will start with the poly disk. So with the poly disk, I can look at the plane that I want to create, or you can even go out into the top view, okay, and click on poly disk. Now you can see my mouse pointer is pretty much floating. I haven't snapped to anything, but you can see there are many lines on your screen, and they are called grids. So here, excuse me. So here I can use one of these grid snapping in bottom right, grid 1, grid 2, grid 3. So I'll just click on grid 2, and I can snap my center of this disk here. So I'm going to click and drag. Let's say it's about like 8 inches wide, and then it's asking me for an internal diameter. I can give any value, or I can just move into the center where I started, and it will just make it a 0 internal diameter. Right now I have an external diameter of about 8 inches. So I can type in an exact value. And once I'm done, I can also say, hey, how many angular subdivisions and radial subdivisions do I need? And each of the Polynubs objects, if there are such parameters, they'll be available here. So by angular, I mean these pies that you see here. Right now, there are 8 pieces of this pie, and I can make them into an odd number or an even number, whatever you want. So for this exercise, I'm just going to keep it in 8 because we're okay with it. And the radial subdivisions are, of course, the radial edge loops that you can see here, and we have 4. And if you think you don't need 4, you can always reduce it. For this exercise, I really don't need it, but let's just leave it at the default. It's okay. So once you create your basic primitive, you can right-click swipe to exit. Now I'm in the top view, right? So when I hit the home view, it usually brings me to the default view, but I want to work in a perspective. So I'm going to double click on this top header to get out. And here I have created the basic primitive, and you can see that the edit polynums is already open. So first thing I want to do is basically extrude all of these faces by 1 inch. So what I can do is I can either do a box selection to select all of them, or I can even do right click, select all faces. And when I select all faces, I get these handles for each and every face. But since my selection is everything, I can select any one of these handles and drag it. So let's just come here. I'm not holding any modifier key. I'm just using my mouse. So I can click and drag it. So you can see when I drag it, there are different ways. There is a free extrusion, or there is a, if you hold shift, you can extrude it along Z or X, so that's what, that's a quick modifier. But you can also see that there is a small micro dialog that has popped up here saying how much you want to extrude it by. And 1 is a good number for me, so I'm happy with it, but you can type in anything you want. When you hit done, it's going to finish the extrusion, but you can continue extruding it if you want. So I'm happy with this right now. I'm going to right click and swipe. So by default, you can see this is what it created, a very soft looking, it almost looks like a cookie. So I just started with the polydisc and extruded it. This is the nerbified version, as we call it. I mean, it's a smoothened version of a mesh that is underlying. To actually look at how the mesh is laid out, you can hit N on the keyboard, and this is what it looks like underneath. So I have created a disk and extruded it, and this is what it looks like. But when I hit N on the keyboard, I can toggle between these two views. And as you explore these polynubs, you'll find yourself toggling between these, because in some cases, as the model becomes complex, you will like to look at it in this format because it's easier to select the edges and so on. But in this smoothened format, you can do more things that give you direct visual feedback. For example, let's go at the edges. So I hit S on the keyboard for edges. And I know I can select some of these edges, but if you hold Alt, you can select an entire loop of edges. So I hit Alt, and I want to add the bottom loop also to my current selection. So I'll hold Control and then hold Alt again, and I'm going to click on this bottom. So I have these two loops selected, and you can see now that we are in the edges mode, and there are some options for creasing. So creasing lets you define the strength of an edge. So here I have a sharp creasing effect that makes it completely sharp, but I don't like it. I generally like something with some radius. So I'm going to use this strength aspect. You can see the strength of one is not the same as sharp. So you can see that I get a very nice smooth radius, although we can't really control that, but I cannot get that with the sharp surface. So I'm quite happy with this result, and this is something you can only see in nerbified format. So if I'm in this view, I can't really tell what's going on. So I generally look at some of these modifications in this view. So once you do that, you can just right-click swipe to finish, and we created the first part here. You can see the bottom part. This is going to be the coaster that we are using. And then in order to actually continue modeling, what I can do is I can start off with the same polydisc to create the top of the mug, or I can use some other primitive. So before we do that, let me just quickly rotate this model by about 20 degrees. I'll tell you why in a minute. So since this had 8 pies, 360, every angle is 20, and I just rotated it by 20 so that it's in the center here. So Once I have this, I can think about how I can design the top part of this mug. And for that, I will use a polycylinder. Polycylinder is just a cylindrical mesh that is similar to the cylinder in the surfaces menu, but it's just that in a mesh format. So I'm going to click on the cylinder, but before that, I want to just look at the top view and select the cylinder. So again, I'm going to snap to this part, which is the center here, and my radius, or rather diameter on the bottom, is going to be like 6 inches. We can always change it. Once I finish creating the bottom diameter, I'm holding Shift, right click to rotate, and then just dragging my mouse to see, moving my mouse to get a certain height. You can even just eyeball it, but I know about 10 inches will be good. So I'm going to give it a 10-inch height. But here I have a lock that basically locks the top and bottom ratio of the radii. But if I unlock it, I can change the radius on top. So I can say this is like 9 inches. The bottom is 6 inches. Okay. So once I have this, I can even add some more vertical subdivisions. So you saw that we had angular and radial for disk, but for cylinder, we also have a vertical subdivision, and that is something you can add or subtract. So 4 is the default, and I'm going to leave it at 4. So I'm going to click this green check mark. So again, as soon as you finish creating a primitive or any polynomials object, this edit polynomials will become active. But I can get it out of the way because I want to first move it into place. So I'm going to select this and hit W on the keyboard for the quick move tool. And I'm going to move it up like by 2 inches. I'm happy with that. Now I'm going to double click this, and I want to get a shape like the one I have on the left side here, a very smooth cup shape. So the way you can do it is you can just can select a bunch of edges and just skew them a little bit. Okay, I'm going to show you how to do that. But before that, I want to turn off any snaps, because whenever I'm modeling with polynomials, snaps are a bit too clunky and I want some fluidity. So I'm going to turn off all the grid snaps here, but I'm still using other snaps. So here I have this first loop. I'm going to hold Alt and click on it. When I click, of course, the entire selection loop is selected. And in the front view, if I click on any one of these edges and drag it, I can skew them. So I'm basically scaling them, and I can just look at it and eyeball it. Again, I'm going to hold Alt, click this one, and scale it. You click outside in an empty area, it's going to deselect everything. Then I hold Alt, click once more, and I get this shape. So I'm pretty happy with this. If you wanted, I could also increase the top of the cylinder, So I can hold Alt, again go to the front view, and just pull it out slightly. So I can hold Shift if I want to pull it out along the direction. Otherwise, it becomes like this. So I'm holding Shift now to do it this way. Okay, so I'm happy with that. I right-click, swipe to exit, and I get out of here. And I need to create the shelling, or I want to make this hollow right now. So I'm going to select N on the keyboard to make it into this shape. And here I'm going to show you an advanced selection method for polynomials. So by default, when I go into faces, I want to delete all of these faces one by one. It's going to take a long time. So instead of that, I'm going to use something called as an advanced selection. So if you right click, you can say advanced selection. So with advanced selection, the handles slightly change. And you can see that they have these 4 arrows. So if you want to select an entire loop of surfaces, you just select the arrow here. So I'm going to select this arrow. So it's going to select the entire loop. If I select it again, it's going to deselect it. So if I want to select the entire edge faces on the top here to delete, there are a couple of ways, easier way to do it. If I click on this arrow here, it's going to select entire loop up until the center. And then when I hit this secondary arrows again, it's going to select the entire loop. So you can also do this. And I'm not holding down any modifier key, so I'm just selecting it. So in advanced selection mode, everything gets added to the selection by default. So I just click this, this, this. So I've selected all of these. Now I want to get out of the advanced selection mode before I do anything. So I just do right click and say, and remove this. And now I'm in the regular mode, and I'm just going to hit delete on the keyboard and delete this. So here I am, I've deleted all the faces on the inside, but the bottom is intact. So now I can go ahead and add some thickness to this. So what I'm going to do is in the same faces mode, I'm going to do select all faces. And I'm going to go to one of these interior faces or the inside of any face and just click and drag inside. Okay, so when I move my mouse, you can see that it's rotating slightly, but as you move closer to the axis of it, the blue dotted line will show a red, red becomes red, and that means you're going on the normal and you'll be fine. And I will type in a value. Just let go of the mouse and I type in a value of 0.5 or even 0.75 inches and hit done. So this way we started with the cylinder and quickly manipulated it. Now when I hit N on the keyboard, this is what it looks like. Again, as I was saying earlier, the top seems to be very smooth. I can make it a bit more sharp by adding creasing effect. So I'm going to hold Alt and select this loop, and Control Alt and select this loop, and just increase the strength a little bit. If you want, you can add a strength on the inside too, and you can get the same effect by adding another loop at the very top. But adding loops to the top makes the model more complex, so you can rather use the edge creasing instead of adding another edge or even adding a chamfer. But let me show you what I mean by that. So when I hit S on the keyboard, let me select this edge and remove the creasing to make it 0. Okay, it removed for both. So, but let me start by adding it to both. Deselect everything, select only the outside, make it 0. So I have this outside edge that is basically smooth. So here, a couple of ways to make this sharper would be to add another edge loop closer to the top edge like this, you see. So this gives the same effect, but I'm adding extra geometry here and just making it more complex. Or I can even do, select this one and I can chamfer it. So if this edge has no creasing like this, I can just, if you move your mouse over one of these handles, it's saying Alt to chamfer the loop. So if I hold Alt and click, I can add a chamfer to this. I can't control the angle, it's by 45 degrees by default, or the radius, but the shorter the distance between those two, the sharper it'll be. So this is another way to add some more detail. But for the purpose of this, let's just add the creasing and leave it there. So here we are, and the last step would be to actually merge these two together. But before doing that, I'm going to rotate this also by about 20 degrees. Let's do 22. Okay, so here we are. These two are separate polynubs objects, but we can also merge them into a single object by using a merge polynubs. The reason I'm using merge is because I want to treat them as a single body. So right now when I hit S or D or A on the keyboard, I'm not getting anything at the bottom. So let's do a merge between this and this. Right click, swipe to finish. Now these are basically treated as a single polynubs object. And so when I hit A or S or D, everything is highlighted. So now we need to create this quick handle that merges these two, and it's pretty easy to do. Before that, I do that, I want another face at the very top because I want to merge it into that. So to add a new face, I'm just going to split the outside into one more edge like this. I'm going to add an edge loop. Okay, so I added an edge loop that gave me this new face. And now I can create the feature that I was talking about. So here I can, before I do that, I want to show you, actually select two faces. So I'm going to select this face, hold Control and select this face. And when I have more than one face selected and you click on this extrude handle, both of them should be extruded. So let's extrude it and see what happens. Okay, so you see there's something funny happening, which is basically they're going in the opposite direction, which is not what we want. So I'm going to hit done and Control Z to end this. The reason that this happened is because the normals are inverted. So when I do right click, actually go into edit mode, double click on it, go into edit mode and right click and see show normals. You can see that the normals for the top of the object are basically inverted. So how do we fix that? We just select all of these faces. Okay, I'm in faces mode, right click and say invert selected, and they will all be inverted. So now when I repeat the same operation that I did earlier, holding both of them Control and dragging, it should work as expected because the normals are now unified or the same. So I'm going to extrude it twice by about an inch. And now I have these two parts that can be easily bridged using the bridge command. So I'll hit N to switch back here. With the in the faces mode, I'm going to select deselect everything and select this one, hold Control and select this face. Now with these two faces selected, I can do a bridge. So this is a quick way to create a complete bridge between. So when I hit N on the keyboard now, you can see that it has bridged everything. But I'm not really happy with the shape, so let's see how we can edit the shape of this object now. So we can do a double click on this. When you go to vertices mode, so we can just do a box select on these and scale these points inside together. So I'm going to hit move. In the move tool, you can change to scale. And if you look at the y-axis, that's where we want to scale it along. So I'm just going to scale it inside until I'm happy with the shape, about 0.6. Right click swipe once to get out of the move tool. And you can see what has happened here. And now it's time to just make some quick or finer adjustments to your model. So here we are in vertices mode, so you can select all 4 of these. And when you move your mouse close to the vertex, you will see these arrows. They let you drag vertices in a certain direction. So I can do this. I'm just going to select some of these and then move it because I just want to give it a nice smoother look here. So same thing at the top. I'm just going to select some of these, move them. Not using the move tool here, so it's faster because the vertex moves along the edge. And once I have this, I am pretty happy with the layout. So here you saw how quickly we started with a simple polydisk and created the entire mug here. And of course, now this is ready for, you can just prepare it for a 3D printing if you would like. So how would you do that? First of all, let's hide this. And I want to measure this object just to make sure. So I can select it and say measure. So you can see it's about 12 inches by 11 by 8. So that's the size. So you can always check whether you've done you've fit the bounding box or whatever measurement you started with. Once you have this, you can say NURBS to poly. So basically now we need to convert this to a format that is recognizable by the 3D printer, the STL format. So I'm going to select this and click on this. And when I right click, it's going to create a very crappy looking interpolation because we are not specifying anything at the moment. So once we do that, if you just expand this a little bit, you can see some more options in tessellation. So in tessellation, the main option that I usually work with is phase dimension, because that lets you define the details or the detail level. So the smaller the face, the more detailed and heavier the model is going to be. So let's start with a face dimension of, no, let's do 0.5 inches. Okay, that's the min. I hit tab and I hit 0.5 again. So this is the min and max are both set to 0.5. And you can still see it's a very chunky looking model. So you can turn off triangles or have some more options in tolerance and so on. But I think I need to go smaller. So let's go minimum is 0.25 and maximum is also 0.25. So you can see that the model is getting finer and finer, but this is only if you think that you're not going to do anything after printing. So for example, if you think about doing any kind of sanding or smoothing it out, you don't need such a small space dimension. But here we are created a NURBS to poly on this, and it's ready to be printed. So the way you would save it is just select it and say File, Save Selected. And here I'm going to say STL or stereolithography, and you can just say OK. So when you hit OK, it's going to say what kind of format. You can just say the defaults are fine and hit OK, because you want to export whatever is there right now. So it's going to export this as an STL file. So just to double check, I'm going to open that file, mark.stl. I'm going to say yes. And when you import it, you can either import for modeling or rendering. We're just looking at it now, so I'm going to import for rendering. And this is the file. So it looks pretty good. And you can send this to a printer and it will probably come out pretty awesome. So that's a quick look at how you can use polyNURBS. But let me show you some other examples where polyNURBS is more often used. So I'm going to open a Okay, so I have this file here. So this is basically like an ottoman that you would have, that you can create inside Studio. I'm going to show you how we can create some of these features, because a lot of our customers use this to create this side of dimples. And it's pretty much how you would create a cushion in terms of creating the main surface body and then just using the vertices to chamfer it. So we can either create both of these using polyNURBS, or we can mix and match. Let's look at both. Let's look at the polyNURBS way, because that's the focus here. So I'm going to start in the top view, and this time I'm going to use a Polycube. Okay, so a Polycube is what it is. It is a Polycube which has subdivision aspects along length, width, and height. So I'm going to use Alt-2 to snap it. So I'm going to start here, about 7 inches. So this is not really to scale, of course. 7 by, no, about this much. So 23 by 11. So here I have the basic shape, and then when I define the height, I can define it exactly the way I want. So let's say 11 inches again. So this is a Polycube that has absolutely no subdivisions. It's 1 by 1 by 1. So as I increase it, you can see that it starts taking shape. So I will make it 7 because I want odd number on the top, and along the width I can add another odd number, maybe 5. And along the height I can add 5 or 4, it doesn't matter. So I have this shape that I got quickly, and I swipe to finish it. And again, as I showed you before, I can scale this object to the if I want to change the shape. So the bottom is on the ground, but the top seems to be not. It's very, very high, very tall. So let's just change it a little bit. So I can just select all of the points that I want to scale. So I can select all of them, hit W on the keyboard. But if I scale it, it'll probably scale around this point. So I'm going to do hit Shift to move the manipulator first. I'm going to click and drag it here because I want to scale it down from here. Once I'm done with this manipulator moving, I hit Shift again to come back and go to Scale. And I can just drag it down this way to change the size. So let's make it 0.6. And right click swipe twice to get out. So again, I have this the surface, and I can use this as a building block for the next one. So what I mean by that is I'm going to go to N. I'm going to hit D on the keyboard. I'm just going to select all of these. Okay, so that I select the top faces, and I will hold Control. So let me go to the front view. I can just select these ones and deselect the ones that I don't like. So instead, you can also go to the top view and just use the advanced selection as I was showing before. So let's go to advanced selection, select this and select the last one. And then when I hit the arrow, it's going to select all of them in between. I can propagate. If I hit this, it'll propagate all the way. So I want to just go once. So I can do Alt click to go once, but it selects everything. So let's again select this and hit the arrow, select this, hit this arrow, and we're going to select the remaining objects this way. So I have these. So the reason I selected the top is I want to extract these faces. So I'm going to do right click, and I'm going to, I have to be in polynubs, obviously. So I'm going to do right click, get out of advanced selection, and then do right click and say extract these selected faces. So when I extract, they become a separate polynubs object. So if I hide it, you'll see that there's a hole here. So again, we'll do the same thing as we did before. D, select all, and then quickly do an extrusion on the inside. So about 0.5. Okay, so I bring back the other polynubs object here, and again hit D, select all, then just extrude it up by about 3 inches or 2.5. So I have this now. I'm just going to select the boundary edges, holding Control and Alt. And I will make them sharp here because I don't really want creasing. Or if you're again familiar with the creasing, I can do this instead. So now I have this top and bottom, and I can look at how I can create those dimples. So I have these different vertices here. So what I can do is I can just select some of the vertices that I want to be part of that design. So I can say I want this. So right now you can see there are 4 in between. So we can delete one of these loops by holding, selecting the loop and deleting it. The reason I'm deleting is because I want an uneven number here. I'm going to delete this. I'm going to select this loop, hit W, and I'm just going to move it in the top view. I'm just going to look at the position, maybe turn off grid snapping and move it to the center. Okay, so this way we have an even or an odd number of vertices here. So I'm going to select every alternate vertex like this. So I'm holding Control to select this. Okay, so these are the ones. Once you have these selected, I can do a right click and say chamfer. And I can click and drag this to chamfer it out. So I've created the chamfer of all of these. So of course I didn't have an odd number along the x-axis, so that's why it looks funny. But once you have selected the chamfer, you can hit D and it will quickly turn it into a face selection. So with the face selection, I can just push this down to create the dimple. So here I'm pushing it down. And right now, what I want to do is I want to make these dimples into a different selection group. So in Studio, you can create selection groups that make it easier to apply materials later on. So with these selected, I'm just going to click on selection groups for faces and click on this folder to add those 10 faces into this group. And I'll do select invert and click on the other folder to add the remaining here. So the reason I did this is because I want to use them as separate materials. So I'm going to right click swipe. So here, when I select the group, I can, once they're selected, what I can do is I can extrude them again once more to create this dimple. So now when I hit, you can see that you got this effect of creating these dimples and these beads along the surface. And you can also do some more options, some more additional details using the same chamfer technique. So if you select the end points and do a chamfer, it's going to give a different look here too. So a lot of things can be changed. You can also add some more chamfers along the edges if you want. So yeah, so that is a quick way to create some objects like these. And the last one I want to show you is actually something to do with morphing an object in Studio. So I'm going to open this example. So here, this was created completely in Studio. Again, a quick polynubs concept. So if I hit N, you can see that this is the way the edges are all designed. And as I was showing earlier, you can use some additional tools to actually manipulate these. For example, let's say that I'm not really happy with the, I'm holding Control, Alt and selecting this, only this loop. It's not really looking very nice. So if I want to align this to a curve, I can just say, go to vertices mode. So all these vertices are selected. And here I can say align to a curve. And here I can give some curves. I have some options for interpolated curves. So I have a auto CV for 7 and for 9. So these give me some ways of changing it. So let me go to, I think this is the 5 CVs. So I can go to my front view. When I pull on one of these, you can see that the shape of the curve will change and also the vertices will move. But I didn't have any symmetry on, so this side, nothing happened. So I could have turned on symmetry and the same thing would have happened to that side. But that is one part of it. But the most interesting thing is how you can morph this. So in deform, you have something called the cage tool. So a cage tool can be used on almost anything to morph. So here, let's just see how we can morph it on this polynubs object. If you select the cage tool, by default, a giant cage is added around the object, but you can always edit the shape. So once the cage is added, I'm going to do move tool and go to scale. And I'm going to change the size of this cage. So let's say you want to morph only a small portion of the front of the car. So I'm going to create a cage this way, go back to move, and I'm bringing it out into the front. Okay, so this is the only part that I want to touch. I wanted the rest to remain unchanged. So once I create the cage, I right-click swipe to get out of the move tool, I can see area of influence. So when I turn on area of influence, I can see which part of the model am I really modifying. So when I move the cage, it'll show me where I'm editing. So let's say I just want to work here at the top. Seems like the influence is a bit too much, so I can always scale that part of the bounding box or the cage to make it smaller and finer, and move it out if I want to only work on one part. So once I have the cage here, I can add some sections because that gives me more control over morphing. So here in the sections, I can say add sections, and I just add a bunch of sections. Hit shift to actually change the the axis. So once I have this, I can say I can right click swipe, double click to come back to the cage, and select all of my points, and I can spread them evenly along the 3 axes. So I'm going to say spread evenly along green, blue, and red. So now I have these points that can be used to morph. So now I can go to the morph phase, and when I select some points, let's say if we select bunch of points here. Let me look at the top view for, yeah. So let's say I just want to morph some points here. So I'm going to select these points. And when I move them, so I'm just using the same vertex movement, I'm moving only those points on my morph. So I can move it here, and I can see that how much effect does this morphing have on my underlying cage. So I can change it from 0 to 100. So this way you can add many cages around the object, and this can be applied to almost any object. And I think in the upcoming webinars, I will cover some more in-depth cage tutorials in the sense that I'll show you some more simpler objects that can definitely benefit with the cage. So to wrap it up, at least for the polynobes aspect, it's a very, very deep topic, at least in Studio, for us to cover, but I hope it gave you an idea of what you can achieve with it. It's a very, very intuitive tool, and I recommend and I highly encourage you to play around with it and really see the power and potential that it has. And in conjunction with other tools that we offer, I'm pretty sure that Studio is an undiscovered gem, and you will definitely find a lot of value by incorporating it in any part of your design process. So in the subsequent webinars, we'll cover topics that are varying in terms of how to mix and match tools, how to bring in models and edit them, and how to also create renderings and so on. So I hope it was helpful, and thanks a lot for joining me. Now I'll hand it back to Barbara.
Thank you so much, Arjun. Wow. Let me share my screen for a second. If you want to start modeling right away, like Arjun has been doing, ask us for the free trial promotion, 90 days of free Altair Inspire Studio. Arjun, how long do you think it will take for somebody to master the software?
That's a good question. If you were talking only about what I showed today, like the polynobes, it's probably a couple of hours, maybe 3 to 4 hours to get a really good handle of it. I would say maybe 2 to 3 days to at least become very familiar with the UI and with all the other tools, because it's just mostly about the way you learn a new language is by just speaking. So it's just about practicing a new technique. That's it. And people who are familiar with modeling will feel very comfortable.
That's why we want you to get your hands on Inspire. So email sales@novage.com and request it, and we'll be very happy to let you play with it. And thank you for attending today. We're wrapping it up. This is where you can find information about Inspire Studio. You can always call us. Our phone number is on every page of our website, and we're always here for you. Thanks again for joining us today. Looking forward already to the next webinar. Stay tuned and have a great rest of the day. Bye-bye, Arjun. Thank you very much.
Bye. Thank you, Barbara.